Hello everyone. In this session, we will discuss about what is Z transform and the properties of Z transform and the methods of computing inverse Z transform. Z transform is the mathematical tool used in the digital signal processing in order to convert the time domain representation of the signal into Z domain representation, and also it is mainly used to analyze discrete time signals as well as system. The Z transform of the signal can be obtained by using the expression x of z equal to summation n equal to minus infinity to plus infinity x of n z power minus n. Z transform can be computed for bilateral sequence as well as the unilateral sequence. For the bilateral sequence, the limit may vary from minus infinity to plus infinity, whereas for unilateral sequence, the limit will vary from 0 to infinity. The relationship between Z transform and DTFT is DTFT can be obtained from Z transform just by replacing Z by e power j omega. Now we'll see the one example problem for the computation of bilateral Z transform. Find the Z transform of the sequence x of n equal to 1, 2, 0, minus 4, 3, 2, 1, 6, 5. Here at one position the arrow mark is given which represents the origin of the sequence. That means which represents the x of 0. The left hand side of the arrow mark represents the negative samples, whereas negatively positioned samples, whereas right hand side of the arrow mark represents the positively positioned samples. Now we need to use the for the computation of the Z transform, we need to use the formula x of z equal to summation n equal to minus infinity to plus infinity x of n z power minus n. Here the limit for n will vary from minus 4 to plus 4. After substituting n equal to minus 4 to plus 4, we need to expand the summation. After expanding the summation, we need to substitute the values of x of n. That means at the place of x of 0, we have to put 3, and in the place of x of minus 1, we have to put minus 4, and x of plus 1, we have to put 2, and so on. Similarly, at x of 4, we have to put 5, and x of minus 4, we have to put 1. Then finally obtained a sequence x of z equal to z power 4 plus 2z power 3 minus 4z plus 3 plus 2z power minus 1 plus z power minus 2 plus 6z power minus 3 plus 5z power minus 4. Now we'll discuss about the various properties of Z transform statement as well as the proof. Now we will see the statement and proof of linearity property. If as per the statement of linearity property, if the Fourier transform of x1 of n is x1 of z and the Fourier transform of f2 of n is x2 of z, then the Fourier transform of a into x1 of n plus b into x2 of n equal to a into x1 of z plus b into x2 of z. In order to prove this property, we have to start with Z transform formula. As per the Z transform formula, we know that x of z equal to summation n equal to minus infinity to plus infinity x of n z power minus n. So in the place of x of n, replace by a into x1 of n plus b into x2 of n. Then distribute the as per the distribution property, we can able to write summation n equal to minus infinity to plus infinity x1 of n into z power minus n plus b into summation n equal to minus infinity to plus infinity x2 of n z power minus n. Then first half of this expression can be written as a into x1 of z plus second half of the expression can be written as b into x2 of z. The statement of time shifting property is the Z transform of x of n minus m equal to z power minus m into x of z. In order to prove this property, again we have to start with the definition of Z transform, which is nothing but x of z equal to summation n equal to minus infinity to plus infinity x of n into z power minus n. In the place of x of n, we need to replace x of n minus m. Then put, let us take n minus m equal to p, then n equal to p plus m. Then you substitute these things in the Z transform definition. Then by rearranging the terms, we will get Z power minus m summation p equal to minus infinity to plus infinity x of p Z power minus p. The function summation n equal to p equal to minus infinity to plus p plus infinity x of p Z power minus p can be written as x of Z. Yes, the time shifting property is proved. The statement of time scaling property is Z transform of Z naught power n into x of n is equal to x of Z by Z naught. In order to prove this property, we need to replace x of n by Z power n x of n in the definition of Z transform. After the replacement, we need to combine the Z terms. Then finally, we will get summation n equal to minus infinity to plus infinity x of n is to Z by Z naught power minus n, which can be written as x of Z by Z naught. Next, the time reversal property is the Z transform of x of n is x of Z, then the Z transform of x of minus n is x of 1 by Z. This can be proved from the definition of Z transform just by replacing x of n by x of minus n. Then minus n can be written as p just by replacing minus n equal to p. Then in the place of n can be replaced by minus p. Then finally we will obtain x of 1 by z. Now we'll see the statement and proof of convolution property. As per the convolution property, if the Z transform of x1 of n is x1 of z, then Z transform of x2 of n is x2 of z, then the Z transform of x1 of n plus x2 of n equal to x1 of z plus x2 of z. To prove this property, we need to consider the Z transform definition. As per the Z transform definition, Z transform of x of n equal to summation n equal to minus infinity to plus infinity x of n z power minus n. In order to prove this property, replace x of n by x1 of n convolution x2 of n. After replacing, just substitute convolution formula. That means x1 of n convolution x2 of n can be written as x1 of m into x2 of n minus m. After that, rearrange the terms. After rearranging the terms, put n minus m equal to p. Then minus z power minus n will become m plus p. After that, just by rearranging the terms, finally we will get x1 of z into x2 of z. Now we will see the differentiation in Z domain property. If Z transform of x of n equal to x of z, then the Z transform of n into x of n equal to minus z dx of z by dz. In order to prove this property, again we have to start with the definition of Z transform. And then in the definition of Z transform, replace x of n by n into x of n. After replacing n by x of n by n into x of n, differentiate both the sides with respect to z. Then we will get dx of z by dz equal to summation n equal to minus infinity to plus infinity minus n x of n is into z power minus n minus 1. Just by replacing the terms, we will get minus z dx of z by dz equal to summation n equal to minus infinity to plus infinity n into x of n z power minus n. Hence the property is proved. Inverse Z transform is used to convert complex Z domain representation of the signal into time domain representation of the signal. Inverse Z transform can be performed by using either power series method or by using partial fraction method. Now we will see the example problem of computing inverse Z transform using partial fraction method. Find the inverse Z transform of x of z using partial fraction method. X of z equal to z by 3z square minus 4z plus 1. The solution is divide both sides by z. Then we will get x of z by z equal to 1 by 3z square minus 4z plus 1. Then we have to apply partial fraction. Before applying the partial fraction, we need to factorize the denominator. Then x of z by z can be written as a by z minus 1 plus b by z minus 1 by 2. Then we have to find the a and b values. then a value is obtained as 1 by 2 and b values are obtained as minus 1 by 2. Then substitute the values of a and b. Therefore, x of z by z can be written as 1 by 2 is by z minus 1 plus minus 1 by 2 by z minus 1 by 2. X of z can be written as 1 by 2 by 1 by 2 into z by z minus 1 minus 1 by 2 z by z minus 1 by 2. If you take inverse z transform for this given sequence, means finally we will get x of n equal to 1 by 2 into u of n minus 1 by 2 into 1 by 3 power n u of n. The second example problem is computation of inverse Z transform using partial fraction method. X of Z equal to 1 by Z into Z minus 1 into 2Z minus 1. Use partial fraction method to compute the X of n. Now we have to use partial fraction method in order to compute A, B, C values. Then A value is obtained as 1, B value equal to plus 1 and C value equal to minus 4. Then substitute the A, B, C values and take inverse Z transform. Then final x of n can be obtained as a del of n minus 1 plus u of n minus 1 minus 2 into 0.5 power n minus 1 into u of n minus 1. The third example problem is find the inverse Z transform using partial fraction method where given x of z is x of z equal to 1 by 4 power into z power minus 1 divided by 1 minus 1 by 2 z power minus 1 into 1 minus 1 by 4 z power minus 1. The solution is first we need to compute the a-b values using partial fraction method. After computing the a-b values, we have to substitute a-b values and we need to take the inverse z transform. The a value is obtained as 1 and b value is obtained as minus 1. Then finally, x of z by z is equal to 1 by z minus 1 by 2 minus 1 by z minus 1 by 4. Then x of z equal to z by z minus 1 by 2 minus z by z minus 1 by 4. Then if you take inverse Z transform for the above sequences, then we'll obtain x of n equal to 1 by 2 power n into u of n minus 1 by 4 power n into u of n.